Hello, welcome. Let us talk about the digital image processing, and I want to take you to the goal of image processing. The goal of image processing, basically we have two aspects. One is that we need to improve the pictorial information. We need to capture information from the image. And the second aspect is that we need to process the image in order for efficient storage and of course transformation and transmission of the image in order to receive the information. These are the related areas. When we talk about image processing, we mean image processing. Our eye is the best image processor you can think of because it connects to vision. So that's why it comes to computer vision and also computer graphics. So image processing is a vast area where you can actually apply your knowledge in robotics, starting from robotics, Internet of Things, to AI, to blockchain, to all aspects of cyber-physical system. Take a look at image processing. Image processing practically happens to be a building block where we give a two-dimensional image. 2D image, generally we are not considering 3D image. Image processing practically tries to understand the edge detection commonly, transform from time domain to frequency domain because we need to apply special filter, frequency Fourier transform, and then we need to enhance the image, we need to reconstruct the image, and ultimately coming out is another two-dimensional image but with a different processing. Take a look at this image processing enhancements examples. These are different pictures and you can see as we move from up and down, you can see the difference between the contrast and the detail information. So enhancing the image is changing its properties in terms of contrast, brightness and other aspects, other features of the image. Image restoration is another example that you have an image which is partially, distorted or maybe distorted, and then you reconstruct that image and restore that image. You may have image processing, remember, actually, is when Hubble telescope was launched in the year 1990. It took a lot of image of different objects, and there was incorrect mirror. So Hubble images all became useless because of its incorrect mirror, made many of Hubble's images useless, and ultimately we applied image processing technique to fix this and to come up with a real image. So image processing, one area is called image compression. What do you do in the image compression? You start with, look, there is an input image and then you are pre-processing, and ultimately after the pre-processing you do encoding. Encoding why? Because you are actually transforming maybe 1 and 0s into some other numbers so that it is encoded and it is compressed file. And when, on the other hand, decompression starts with, from compressed file you decode, reprocess, and then you get the decoded image. Computer graphics, on the other hand, you start with a 3D geometric data. In the graphics processing, what you do, you compute light interactions, geometric projections from 2D to 3D, and ultimately come out, you basically produce an image out of a 3D geometric data. So an example of computer graphics like this, you have an image and you start with a different projection. There are synthetic cameras and ultimately there is a geometric model. So the output, there is a reflection of light. You can see on the top there is a reflection of light. The ultimate reflection is coming out of synthetic camera and that is producing an image. So how you are actually producing from graphics to image. And then computer vision is an example where you give 2D image and computer vision does actually reconstruction, analysis and recognition, and you come up with a 3D geometric data for understanding the object. So take a look at computer vision. You have a real scene whereby you have two eyes is representing two different camera. There is a reflection and ultimately the output is generated as a model, and you can understand the 3D geometric data. As a computer vision output is always a model. So the key processing of the image, it happens to be like this. You start with a problem domain, and then from the problem you acquire that image acquisition. When image acquisition is done, you actually have a job now which is enhancing the image. You may enhance the image, you may restore the image, you may do morphological processing, you may do segmentation, you may represent and describe an object, identifying the object. So one hand you have actually, there are two other aspects. One we call image compression, another is color image processing. So you take a look, start with the problem definition. This is a problem. I'm showing you that there is a scene, there is a light reflecting on the scene and you're capturing. So what you do after capturing of the image, you enhance that image. In the second step, image enhancement, and you are actually enhancing, you are changing the light, the color, the black darkness, the brightness, the contrast, and you come up with the image enhancement. Then coming back to image restoration, because partly maybe the image is damaged, so you restore that. And then you come up with a morphological processing, like take a look at this fingerprint. We try to read different ridges, and and all these ridges produces the information. And after that, we basically have a segmentation. We segment that image to identify our interest region. And after that, what happens is the representation and description. We may come up with a more accurate description from the image itself, and then coming back into object recognition, you are recognizing the object. So altogether, it comes into actually image compression is a different technique whereby we discuss differently about image compression, and color image processing actually is different from grayscale or black and white image. So with this, we stop here, and we take a look at further discussions. Thank you.